Hello everyone, my name is Ty Everett, the founding president of Project Babbage, and I've just updated my Babbage Desktop software here to the latest version. And as of the time of this recording, that is 0.2.11. So if I go to my settings here, you can see that the version is 0.2.11. And this version of Babbage Desktop introduces a pretty cool new feature. So let's go ahead and check it out. If I tab over here to a demo app, which I have open, this is the custom contract demo. And so this means that inside of an action in Babbage Desktop, we can now redeem any UTXO on Bitcoin as long as we provide the unlocking script. And that will allow for external sources of funding for Babbage actions. That will allow for the ability of Babbage actions to redeem and then spend a token, spending it forward, because now you can have custom inputs and custom outputs. You can take your custom token UTXO, unlock it however you need to unlock it, and then spend it in a new transaction output. Those are just a few examples of the things that are possible when you have a framework for creating Bitcoin transactions, not only that allows you to have any custom outputs that you want, so op return, custom scripts, sCrypt contracts, STOS tokens, or anything like that. But you can also take those same custom outputs and then spend them in new transactions that allow you to even add money to your Babbage Desktop. So if you spend, if you unlock an unlocking script that allows you to get an extra 10,000 satoshis, then in your Babbage Desktop software here, you'll be able to see an extra 10,000 satoshis in your account, for example, if that were to happen. And so we're going to demonstrate that here. I'm going to go to my actions here, and I have just tested this, but you can see right now, I ran this just 5 minutes ago, and it said that first thing that happened was that we put satoshis into a custom contract. So I've just highlighted that, and you can see that the cost of that, was, what was it? 0.334 cents, so just about a third of a penny there, and it was minus this amount of satoshis. And then when we actually were able to redeem that custom contract, so we locked up 1,000 satoshis in that contract, and then we redeemed it. And so the net result was that a few of those satoshis got spent on the fees to mine those transactions, and there's some fees for when you take an action, etc. But we were able to get a little bit of these satoshis back. So 973 of those satoshis ended up back in the wallet after we redeem the contract. So I'm going to go ahead and run the demo again. The link for this code is in the description of this video. So if you want to check out how to redeem, so first what it'll do is it'll create a contract using a custom output like we know how to do. But then it'll take that contract, that output, and it will redeem it and spend it forward. So this could be an output for a compiled sCrypt contract. This could be any type of custom output. As long as you can get the unlocking script and pass it in, you'll be able to redeem that output. So just specify the TXID, the index, which output of that transaction you want to redeem, and then the unlocking script, and Babbage will unlock that output and use it in your transaction. So you're going to want to sign it with SIG-hash anyone can pay and SIG-hash none, so that when you unlock your output, because and the reason why you want to sign it using those SIG-hash flags is because you're allowing Babbage to add the other outputs and inputs of the transaction that Babbage is trying to create. But that's the only caveat here. I'm going to run this, and we'll see what happens. So first thing that's going to happen is it's going to ask me, do I want to allow, and I think this UX is better than what it was before, so let me know if you think this UX is any better. Do I want to allow this local app to make this, this action? So there it is, there's the first part, and there's the second part. So as you can see in the console, first we created the contract, and here's the action payload there. So the raw transaction, its inputs, MAPI responses, and a TXID. And then we searched for the correct output of that transaction to use, and we found it at index 0. So it's in output number 0 of that transaction. And then we go ahead and we're logging this here. So this is just this is the call that is being made to create action. So we're providing inputs, and this is new. So the call to create action has inputs, and we're providing the outputs to redeem. We're just providing that the index of the output is 0, and we're providing the unlocking script. So finally, at the bottom, we can see that the contract has been redeemed. And if we look in Babbage Desktop, I'll just go ahead and refresh the list of actions here. And now that the new actions have been taken, we can see that this was just a minute ago. So there's another, so this one the cost is a little bit less because there was no action commission taken. So just paying for some transaction fees there, we locked up our output and then we got it back. So looking at the code, how this works is first off, we say we're loading. So basically this is just the Babbage React starter, and I'll have a link to this code in the description. So if you have trouble kind of following along with me as I'm scrolling through the different pages of code on the screen here, just go ahead and check out the link in the description and you'll be able to read through this, and I'll kind of describe these pretty much in order. So going in the handle click function of this app, right? Basically that run demo button that I clicked, we have set loading true. So basically tell the app we're loading. We have two variables. We have a locking script and we have an unlocking script. And I put some comments next to these so we can see what they are. First one is a number. So hex 5D. We're saying op less than op verify. This is a locking script. So the locking script says come up with some number that is less than hex 5D and verify that the number that you provided is less than that, and then op verify, just you have to push an extra true element onto the stack at the end. So this one is basically op true, and then hex 5C is less than hex 5D. So that's what this unlocking script is. So this creates a custom locking script. That's nothing new, but this spends that locking script and allows us to then re-unlock that UTXO. So now we have a complete system for the locking and also the unlocking of value with Babbage actions. So the first thing we're going to do is create the contract, and that's, you can see here, we're putting Satoshis into a custom contract, and we're just going to use an open path key, so that's not too important. The outputs that we're providing is just one, and this one output has a script, which is the locking script, and we're just going to lock up 1,000 Satoshis into that contract. And we're going to, log out what the contract was once it's been created. What we're going to do next is we're going to discover the output index of the contract. So we're just going to loop through the outputs of that transaction that was just created. And then if we find the one that has the same script as the locking script that we wanted to create, then we know that is the correct index. So we just log out what that is onto the screen, and that way we know that we've found the correct index, right? Which of the outputs of that transaction is the output that contains the specified contract that we told it that it needs to contain here. Finally, we come down here, and well, this is a console log of the call to create action, which is identical to this stuff here. So this is identical to this, so we console log the same thing, and we basically say now we're redeeming the contract. And I might actually remove this and make a new commit to this repository, because this log might not be necessary. But again, open path keys, and that's not too important. And instead of providing outputs, we don't care what the outputs are. All we're saying is we want to redeem this input, and then the outputs are going to be automatically spent as change, right, to Babbage Desktop. So you can just specify, well, I want to spend these inputs in a transaction, and I don't care where the money goes. It goes to the Babbage Desktop, to that pool of UTXOs. And so we've got the TXID of the contract. That is an object. So the input Inputs is an object whose keys are TXID and whose values are, everything related to that contract, and then providing the output index and the unlocking script to spend. So we've created a transaction which contains here's the input I want to spend, and here's the script that unlocks it, right? So pretty simple. It just puts it on the screen here. We're console logging, and that's about it. That's really all there is to it. So this unlocking script can be as complicated as it needs to be. If you're doing signatures and op check sig, you should probably sign with sig hash none, sig hash anyone can pay. If you definitely the outputs are not, you can't do sig hash all and predict the outputs, because there's always a chance that Babbage is going to generate a change output. If you want to only use the one input, right, and no other inputs, which you definitely can do. I mean, if we look at this transaction, I don't believe there's going to be any other inputs. So you may be able to get away, depending on the context, if you're redeeming more value than you're asking for, then all of it's going to go to change, and you may be able to sign with sig hash. You won't need to use sig hash anyone can pay. So so this transaction, let's take a look at it on what's on chain. We'll be able to see that it's got, I think, just one input, and that one input, if I'm correct, I haven't actually looked at this. Yeah, so one input, and that is our, if we look at our script, it's, well, hex 5C, op less than, op verify is our one that we're unlocking, right? And that is being spent to basically Project Babbage, to plus, right, to this plus value here. And that is going to correspond to 973 Satoshis. And if you look over here, 973 Satoshis as well. So that's how that works. It's pretty cool. I think there's a lot of things that people are going to be able to create with this, including custom token solutions. This is open-ended enough. I wanted this to be open-ended enough to support all types of tokens. So not necessarily just your, I don't want to have one single token implementation. I want to make it so that the market can decide what token implementations are going to be the best for people. I want people to be able to create and also redeem any custom outputs that they want to be able to use. So that includes all sCrypt contracts. That includes STAS tokens, everything I mentioned before. So you can check out the code for that demonstration in the video description. There's going to be a link, and it's open source on GitHub. That little demo app where we have a basic locking script, and then we unlock the value of that same contract as well. And there's going to be some other cool things coming out with regard to how can we use this to do something a little bit more, because I'm sure anybody that's messed with sCrypt before already has their wheels turning about, well, could we make it so that you can write sCrypt code, compile it, and then redeem it? And so I'm going to be doing some other exploration about that myself. I haven't really gotten to dig into sCrypt, but now that I've got this built, I feel like I can add something really unique to that system. So definitely check out the code, and if you have any questions about this, feel free to reach out to me. I am on 4 Slack groups related to Bitcoin SV. I am also on Twitter at Project Babbage. So Twitter is not necessarily the best way to reach out to me, but you can reach out to me on the MetaNet ICU Slack group, the Atlantis Slack group, the sCrypt Slack group, or the Bitcoin Navigators. So if you're on any of those 4 Slack groups, or if you're on Twitter, or you can email me, ty@projectbabbage.com, and I will go so far as to set up a call with you. We will figure out all of the stuff that needs to be figured out in order to make your use case work. or I will tell you that, you know, it's just too early, because I had a couple of calls with some people, and there's some things that you can't do in this space yet because the technology isn't as developed as everyone would like it to be. But in fact, it was one of those conversations that got me to try to make this work, so that we can leverage tokens inside of Babbage and other things. But definitely reach out, definitely ask some questions, and I'd love to see what people build with now that we have the ability to create and use tokens inside of the Babbage app ecosystem. So I'm done rambling. Thank you for watching. Follow me on Twitter, subscribe to me on YouTube, and definitely try to build some cool stuff with the new custom input contract redemption stuff inside of Babbage Desktop. Make sure if you use Babbage Desktop that you've updated to the latest version, so you can go to the settings like I did and make sure it's 0.2.11, because that's the only one, 0.2.11 or later. So 0.3 if this is in the future, or make sure you've updated, because it won't work, and this demo won't work unless you're on the latest version. So in the early days, in these alpha stages of these pieces of software, I'm just going to assume that you're always checking and making sure you're on the latest version, because things probably just won't work in weird ways unless you are. So keep your software updated, everybody, and definitely build some cool things with this new thing, and there's some docs I'll link to in the description as well. So thank you for watching.